Probably mostly, I think. I think so.
So I'm gonna do my beloved.
Oh, it's not.
And then I'm gonna change her.
What did the shaded part look like?
And the third day I make up some.
I don't know where I put them. Right here. Here, you can put those up.
Wait, the one there?
All right. Go ahead and get your notes back out. I'm going to show you guys the washer method, which is very similar to the disc method. All right, so I'm going to go ahead and just jump into a problem, and then we'll see what the difference is. So we're going to find the volume of a solid. Formed by rotating the region bounded by y equals x and y equals x squared about the x-axis. So we have a parabola and we have a straight line. So there's a parabola. There's our straight line, and they make this little area between them. Looks like that. So the big difference between the disc method and the washer method is that with the disc method, the curve itself is up against the axis that you're revolving it around. The whole shape was up against that. This time, the shape is not. We're revolving it around the x-axis, but you can see that the shape has some white space. Does that make sense? There's some space in between. So before, we had our shaded region would have been all up against the x-axis when it rotated, and that's what created the full circle. Here, we have part of the shape is against the x-axis, but a lot of it has a space in between. So that means that when you take this shape and you rotate it around, you get what is called a washer, or what I like to think of as a donut. Okay? So you can see how if we look at the parts like right here, that little part represents this piece that's right next to the axis. That is like almost completely filled in. But if you look at this piece over here, when you rotate it around the x-axis, it's going to be hollow in the middle. Does that make sense when we rotate it? And so you can see these pieces out here are hollow in the middle. So instead of making a circle shape, they make like an outer circle and an inner circle. Does that make sense? So if I get more in there, there's our shape, but the inside of it is kind of hollow. It looks kind of like a funnel. Does that make sense? Okay. So here's more, and we can really see it right there. All right, so when we do this, what we do to find the area of a washer is we do the outer circle minus the inner circle, okay? So on here, I'm going to write that my cross section is a washer. Which means we have an outer circle and an inner circle. So the outer circle is going to come from the top curve, or the bottom curve, I guess it depends on the picture, but it's going to be the curve that's furthest from the axis of rotation, right? Because it's going to make a bigger radius. So if this is our axis of rotation, this curve right here is the part of the curve that forms the outside of the circle. This part of the curve right here forms the inside of the circle when you rotate it, okay? So the area of a washer we're going to call pi r squared, where r is this whole thing, minus pi little r squared, where the little r is just that part right there. So big R is the radius based on what's furthest from the axis of rotation. Little r is the radius based on what is closer to the axis of rotation. Okay? Yeah. So if we look at the graph, this part right here would be the big R. And then, I don't think I have another color pen. I'll use black. And then this part right here would be the little r. So as I rotate it around and I make that circle shape, this outside part would make the bigger part of the circle. This inside part would make the little piece of the circle. So when we look at these washers, see how there's like the outer edge of the circle and then the inner edge of each circle? The outer edge comes from this line, and the inner edge comes from the other line. And they make that donut shape. Okay. So for this problem, we know that these two lines are going to cross at 1. We could set that up and solve it. Let's go ahead and do that so we have a good example of that. I'm going to set these two equations equal to each other. X squared equals x. And I'm going to solve that because I want to know where they cross. So x squared minus x equals 0. And if I factor that to solve it, that gives me x times x minus 1. And so that means my interval is 0 to 1. So I'm going to do pi r squared minus pi r squared for my interval. And each individual r is going to be top minus bottom if you're in terms of x, or right minus left if you're in terms of y. So in this case, our top minus bottom is going to be the curve and the x-axis, so we're going to be minusing 0. But if we were rotating it around a different horizontal line, then maybe we would have the curve minus 1, or like the curve minus 2, or maybe we would have the axis minus the curve, which is kind of like we did on number 6, I think. Okay, so big R in this case would be that top curve, which was the straight line. So it would be x minus 0. little r would be x squared minus 0. So the integral that we're working with is from 0 to 1.
Hello. May all students who are participating in the cookie decorating contest for the Key Club please go to B1. It will be during both lunches. Can all students who are participating in the cookie decorating contest for the Key Club please go to B1. It will be open for both lunches.